Black math! Give me some math and I'll give you some black. Black math!
Okay, so we're gonna do, oop, I don't want blue, icky blue. We're gonna do lesson 37 and 38. Everybody see this okay? Is it big enough? Thumbs up, thumbs down, big enough, good. Okay, I think those are thumbs up. Okay, we're gonna talk about equations. So remember, do you guys remember defining equations? What's an equation?
You do one side, you do the other, same thing to the other side.
Okay, yeah, those are the rules of an equation, the properties of an equation of equality. But an equation just has an equal sign in it. So you know what? This, or let me do something a little crazy. Let's do this. This is an equation, right? This is an equation. But
Mr. Flag.
I know. So this is still an equation, but we call this a false equation, but this is a true equation. Good job paying attention though. I should give you a free problem set. All of you, even though I intended to make that mistake, like all of you raised your hand and pointed out. Nice job.
You should give everybody.
Okay, how about I'll leave that up to Mrs. Felmley. And if you guys work great after our lessons, and she tells me that you worked well, then I will take a problem set off of next week's assignments, okay? Or I'll just give you a free problem set that you can use anytime you want, okay? All right, now here's another type of equation. X plus 2 equals 6. Is this true or false?
True. If X equals 4.
All right, that's the key. If X equals 4, then this is true. Okay, this is called an if-then statement or a conditional statement. So this equation is called conditional. There are conditions. In order for this to be true, there are conditions that must be met. I want a helicopter on the roof in 1 hour. No police. No, those aren't the conditions. The condition is just if X equals 4, then it's true. So far, so good? So these are just semantics, just definitions, true equations, false equations, conditional equations. Those are really the only 3 types of equations, okay? Now, you are smart and you can figure out most of these things, but I'm just gonna put some examples on the board here, okay? Let's see here, solve. Okay, I don't know if you've seen this, you've probably seen this word in your math assignments, but solve means find the solution. Okay, so what's the solution? 6, right, so X would equal 6. This is solve means find the solution. The solution to this equation is whatever number makes this a true equation, okay? The solution is whatever makes it true. So X equals 6. All right, what about this? Solve X minus 4 equals 10. What's X? 14, that's right, because 14, if you plug in 14 for X, that makes this equation true. Good. All right. So that's it for lesson 37. Now here's the deal. You guys have been doing problems like this since kindergarten. You just haven't been writing them this way. Like when you say 10 minus 4, what's 10 minus 4? Well, in your head, you're thinking, what plus 4 is 10? Or when you say, what minus 4 is 10? Well, that means 10 plus 4 is 14. So you do this in your head. This is just how we write it down now, okay? And we're going to learn how to solve equations a little bit differently than what you're used to, okay? But for now, just be able to recognize a true equation, a false equation, and a conditional equation. How's that? Thumbs up? Good? Any questions? Okay, let's move on to lesson 38. Well done with 37. That was a quickie.
Xavier has a question.
Yes, Xavier.
I have a question. On find a solution, you put an M instead of an IN.
No, that's just a sloppy IN. You're always judging me.
But it looks like an M.
You look like an M, all right?
No, I don't. I'm an I. A lowercase.
Okay, sorry. I'll put a little dotty thing, okay? Is that better?
No.
Fine. Whatever. We're moving on. Now you don't have to look at my terrible handwriting anymore.
No.
All right, lesson 38. Okay, we're going to talk about rectangular coordinates. So here's what our objective is today. We need to know how to plot points on a rectangular coordinate, or basically a graph, and we need to be able to read a rectangular coordinate and figure out where the points are. So we need to be able to plot and read on a rectangular coordinate system. Okay. All right, so let me give you a little bit of history here. So you guys know that this number line, when we had 0 in the middle and we have positive numbers on the right, negative numbers on the left, some guy, some French dude, René Descartes, and this is how you spell his name. He's French, so it's kind of weird. René Descartes, right? Does that look like Descartes to you?
It looks
No,
like
it doesn't. René Descartes. I don't know how you actually sound it out. But here's the thing. He said, well, what if we wanted to think in more than one dimension? Like, this is just left and right. Well, there is such a thing as up and down too. Or if you think about longitude and latitude, if you know your longitude and latitude, you know almost exactly where you are. I say almost exactly because longitude and latitude doesn't necessarily pinpoint someone in a skyscraper. What else do you need to know besides longitude and latitude to know where somebody is in a tall building? Yeah. I couldn't hear that.
the height.
The height. And you know what they call that in the cool terms? Longitude, latitude, and altitude. Okay. So, but that's a three-dimensional system, but we're just looking at two-dimension. Okay. So they call this the Cartesian plane. Why do you think they call it the Cartesian plane?
Because that's carts.
Yes, right there. So I guess since he's French, he had to name it after himself, but just kidding. I love French. I love French fries. French dressing is kind of gross, but French bread is awesome.
Oh,
Okay. I couldn't hear that, but I'm sure it was clever. Okay, so here's the Cartesian coordinate system, or the Cartesian plane, or the coordinate plane. There's a lot of different ways you can call it, but there are 4 sections. They're called quadrants. The first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And it looks cooler with Roman numerals, even though Roman numeral system is completely useless. It looks cool on clocks and footballs and in like football games, but it looks cool here, I guess. So this is the first quadrant. Here's the second quadrant, third quadrant, and fourth quadrant. Okay. Now over here, you have positive numbers on the x-axis. So this is the x-axis. Anyone know what this axis is called?
Y-axis.
Yep, y-axis. Thanks for shouting out. It's hard to hear unless you're obnoxious, which shouldn't be too difficult for you guys.
Especially me.
It's weird. I can always hear Xavier. That is such a special quality. Okay. All right. So in this quadrant, all the x's are positive, but also look, the y-axis, since it measures north or south or up or down, up is positive and down is negative. That kind of makes sense, right? Just like north and south could be positive and negative, left and right, positive and negative, or left or negative and positive. So that kind of makes sense, all right? So this is all positive numbers, positive x's and positive y's. So the way we write our coordinates is our x value goes first and then our y value. So in this quadrant, we've got a positive x and a positive y. Okay, what about over here? What is our x positive or negative?
Positive X, negative Y.
Okay, close, but see how we go left. We have to go, it's left, so that's a negative x and then a positive y because it's above, it goes up. It goes left and up. All right, what about quadrant 3? Is our x positive or negative? Negative, and is our y positive or negative? Negative. So this is like so much negativity down here, okay? Bottom left corner. You don't want to go there. All right, what about this? Positive or negative y?
Positive X,
Oops, so I said I tricked you accidentally. Positive x, and then what about the y?
negative.
Negative. Good. Okay, so see how these are all the 4 different possibilities. You either have 2 positives, a negative then a positive, a negative and a negative, or a positive then a negative. Okay? So here's the deal. When you plot points, you always go left or right first. Think about it like a ladder. Like if you wanted to go up to something, you have to move the ladder left or right first and then go up, right? You do not want to go up the ladder and then shimmy across. That's very dangerous. You know what the #1 cause of accidents at a construction site is?
Falling from the roof.
Falling off a stinking ladder because people tried, oh, I think I can reach it. I think I can reach it. No, you can't, Indy. Let it go. Okay? You can't reach it. And here's why Beauty and the Beast is my least favorite movie, because you know Belle, when she's in the library and she's like, oh, I want to sing, and that ladder with the wheels on it, she like rolls herself like that. You're not supposed to do that. Even though there's wheels on that, you're supposed to go down and move it because it's easy to move. You're not supposed to go on the ladder and the wheels. That's very unsafe. And she is a poor example for all little girls across the country.
That's
So,
your reasoning for not liking it?
what?
That's your reasoning for not liking it?
Yes, I hate that movie because it's bad. It's bad ladder safety, but it's also bad math.
Dude, that's illegal to not like that.
Don't do that, okay?
Sorry,
All right. So here's what I want to do. I want to try to graph some stuff here, okay? I want to find the points, okay? So let's just, I'm going to do a big XY here. So this is how much left or right you go. And remember, right is positive, left is negative, and this is how far up and down you go. Okay? So if I had a graph here, and I had, and it's hard to see here, but 1, 2, let me try to, okay, can you see where that point is? This is point A. What are the coordinates of point A? I heard a 3, right? Because you go right 3, and then what? A little louder.
4.
Yes, up 4. So how much left or right do you go from the origin? Origin means beginning. That's where you start. You go 1, 2, 3 to the right, and 1, 2, 3, 4 up. Good. All right, what about this? Let's see. Can you see it? Where's that?
B.
I heard a 3.
Uh,
How much? How much left or right do you go? Or let me ask you this: how much right? How far right do we go to get to B?
we go 4.
Yeah, but we go opposite of right, which is -4, right? So we go -4, and then how far up or down do we go?
3.
I see 2. Sorry, it's not exact, but that doesn't really help. Okay, so -4, +2. So left 4, up 2. So see how each of these coordinates has 4 parts. They have a number value, but they also have a direction. Okay, so look at this one. Where do you think C is?
Um, -1, -6.
Yeah, I put -2, -6, because it's hard to see, but I went over 2 and then left 2, down 6. So see how there's 4 parts here? There's a direction, positive or negative, or left or right, and then there's the absolute value, how far you travel in that direction. And then you have a direction here, which is not left or right, it's up or down, and then you have how far you travel in that direction. Okay? All right, I'll do one more here. What's this? What's D?
Um, 3, -1.
Nice. Okay. So I can hear Austin doing that. Does everyone else feel okay with that so far? Thumbs up or down?
My thumbs are up.
Okay, good. All right. So the next part is just making sure we can go the other way. It's great that we can read where the points are. So we're counting how far left and how far up they are, or how far right and how far up they are. Now we need to be able to actually plot the points. Okay. And if I was there, I would have you guys come up and plot these points, but we're just gonna do it, and you guys are gonna walk me through this, okay? So here is example 2, and I want to graph these points. I want to graph these points. Graph A, which is at 4, 2, and I'm going to graph B, which is at 4, -3. And I want to graph C, which is at -4, -3. Okay, so graph. Okay, so walk me through. Here's my pencil. And I want you to walk me through how to graph 4, 2. I'm starting at the origin. Direct me, Siri.
Up 4.
What?
So go to the right 4.
Okay, did I hear somebody say up 4?
Me. Yeah.
Okay, so now good. I'm glad you messed up, because this is the most common mistake. So thank you for pretending like you didn't know the right answer, Xavier. That was very kind of you. Okay.
Well, I did.
So you always go left or right first. So that first number is how far right you go, okay? And if it's negative, you go left. Okay, so we're gonna go right 4. So 1, 2, 3, 4. Now we're here. Now what do I do?
Up 2.
Up 2. There you go, Xavier. See? You were just pretending. Then I'm gonna just put a little A there saying that's where the point is. Okay, does that feel good? All right, next. How do you graph 4, -3?
Carefully.
Carefully. That's always good. 4 to the left because, well, it's a positive 4. So remember, if you want to put a positive sign there, and now you remember there's 4 things. So positive on the x-axis means what? Right or left? What does positive mean?
That way.
I don't know which way you're pointing because it's all backwards. We're going to go right. Yes. We're going to go right. 1, 2, 3, 4. And then what?
Down 3.
Down 3. 1, 2, 3. So basically, this is like 2 turns or just 1 turn. So don't cut through people's yards. You're going to go the long way. You're going to go over 4 and then down 3. That's the quickest way you can get to that house. Okay? Don't cut through yards. That's rude.
But the fastest way is from A to B. Straight line.
You're right. But unfortunately, you can't do that on a coordinate plane. Those are actually called polar coordinates, which we'll talk about in a couple years. Okay? How do you graph -4 and -3?
You don't.
You go to the left 4 times.
Now, this time it is left because it's a -4, 2, 3, 4. And then what?
You go down.
Down 3. 1, 2, 3. So it's about right there. And on graph paper, obviously, this will be much easier. Now, here's what your homework is going to ask you. And I'm going to this is a spoiler alert. So plug your ears if you want to be surprised and challenged by your homework. But it might say something like this. Points A, B, and C are the vertices of a rectangle. What is the 4th vertex?
That would be -4, 2.
Yes. So if you do that, this could be like the 4th vertex. What is 4th vertex of rectangle? Okay. So you can tell because it has to have the same x value as C, and it has to have the same y value as A. So C is -4, y value of A is 2. So -4, 2 would be that fourth vertex, okay? So that's a pretty cool thing. And then it might say, okay, what's the perimeter and area of this rectangle? Can you guys answer that? What's the perimeter and area? Well, how do you calculate perimeter?
All the sides.
Yeah, add up all the sides. Well, there's no numbers. So what do you do?
4 plus 4 plus 4.
Well, not 4 plus, is it 4 plus 4? Yeah, you're right. So 1, or you could just count the little squares. 1, 2, 3, 4, 5, 6, 7, 8. So you got 4 plus 4. So that's this one right here, right? That's 8 and 8. And what about the sides?
4 plus 4.
What's this length?
8.
It's not 4.
Oh, 8.
What? You guys know what this, you can count from here to here too. 1, 2, 3, 4, 5. Or in other words, you're going from 2 to 0 and then 0 to -3. So basically you're going from 2 to -3. So 2 minus -3 is 2 plus 3, which is 5. So the perimeter would be, what is that? 26? And then we would just say units. Area is pretty easy. How do you find the area?
You multiply the two sides.
Yeah, 8 times 5, which is 40. And instead of units, we say square units. Or you could say units and then put a cute little 2 there, units squared. That's fine too. Okay? So that's pretty much 38. So I did like 30, example 3 and 4 all in one thing, because example 4 is talking about that rectangle. Okay? So if you want to look at example 4 on your own at home, you can do that, or right now in class when we have our work time. But let's see here. Yeah, that's pretty much it. Do you guys feel okay about this? Most of you have done this before. Can I get a thumbs up if you feel okay? Okay, awesome.
Black man, give me some math and I'll give you some flack. Black man.